Welcome back students. Today we will discuss in this class principle of conservation of energy. So first of all, what this statement says that according to the principle of conservation of energy, energy can neither be created nor be destroyed, but it can convert from one form to another. So, what is the meaning of that? In this universe, there are various forms of energy, as we know that potential energy, kinetic energy, and other forms are available. All these forms can convert from one form to another, but the total sum of these energies will always remain same, that is it remain conserved. This is what a principle of conservation of energy. So today we will discuss the verification of this principle. Okay, so for that, first of all, it is showing here a one diagram. All of you can see that. What is in that diagram, children? What we have in that diagram, a object under the free fall. This is a ball which is under the free fall. What is meaning of that? Falling freely. This ball is falling freely means this ball is under the action of the gravity only. Suppose at point A, the initial velocity. What is initial means? Initial means the starting velocity. Now at point A, before falling, what will be the initial velocity of the ball? Initial velocity of the ball will be 0. What it will be? 0. When the ball will come down, it will acquire some velocity. From A point, it will reach to which point? B point. And it will acquire some velocity. What velocity it will acquire? Suppose it will acquire the velocity v1. This is v1 is a velocity at point B. I hope it is clear. After under free fall, it will go from B to which point? C. This point is where? Near at the ground. When it will reach the ground, before reaching ground, its velocity will be what? V. So this u is which velocity, children? Initial velocity. This v is what? Final velocity. And this v1 is the velocity at point B. Clear? Now, another thing. The distance of this point A from the ground is what, children? H. You can see here they have shown it. The distance of this object from the ground is what here? H. Clear? Now, next what they are showing, the distance between the point A and the distance between point B is what, children? X. If the total distance from here to ground is H and this distance is X, then what is the value of this distance, children? It is H minus X. I hope it is clear to you. Let's again recall all the things one by one. First of all, there is one ball which is falling freely under the action of gravity. Clear, children? Now, when it is falling freely under the action of gravity, initial velocity of the ball will be 0. Clear? At point A, the initial velocity of the ball will be 0. At point B, because it comes in motion, so it will acquire some velocity. At point B, the velocity will be v1. When it reached near the ground, its velocity will be v. Total height will be what we have here? H. Okay, height. Okay, from the ground is what? H. The distance between A and B is what, children? X. Then the distance between B and C is what? H minus X. I hope it is clear. So let's start doing this verification now. At point A. Now the first let's see at point A. Now at point A, children, what we have here, the initial velocity is 0. If initial velocity is 0, what will be its kinetic energy? What is kinetic energy, children? Kinetic energy is the energy possessed by any body due to its motion. Okay, whenever a body is moving, it is having which energy? Kinetic energy. But here at point A, children, the velocity is what? 0. So if a velocity is 0, the whole kinetic energy will be 0. I think it is clear to you why it is 0 now. Now next move potential energy. What is this potential energy? Energy possessed by any object because of its shape, configuration or its position. Now its formula is mgh. What is m there? Mass of the object. What is g? Acceleration due to gravity. What is h? The height from the ground. Look here children, at this ball is at point A, its height from the ground is what? H. So potential energy will be mgh. Now what will be the total energy? Total energy at point A. Total energy will be what? The sum of these two, kinetic energy plus potential energy. Kinetic energy is 0, potential energy is mgh. The total energy at point A is what? Mgh. Clear this first point? Let's move further now, children. Next point is what? At point B. Now at point B, children, we know the equations of motion. You have studied these equations of motion in your class 9. V square is equal to U square plus 2AS. Now what is this V here? V is which? Final velocity. U is what? Initial velocity. A is what? Acceleration due to gravity. S, distance. Clear? Now at point B. Look children, here it is point B. What is the final velocity? V1. So can I replace this V here by V1? Yeah. What is the initial velocity when the ball reaches at point B? What will be its initial velocity, children? It is 0. So what we will put here? U 0. Now what is A here? Object is under free fall, under the action of gravity. So this A can be replaced by acceleration due to gravity, which is represented by G. What is S, children? That is important now. What is this S? The distance between this A and B. Here what we have? The distance between this A and B is here X. Clear? Now from here what we are getting? V1 square 0. So it is 0 plus 2gx is what? 2gx. Any doubt in this? I don't think so. Again I will explain. V square is equal to U square plus 2as. V is the final velocity, which at point B is V1. A is acceleration due to gravity, so it is replaced by G. S is what? The distance between these 2 points, which is X, and so I have written X. Clear? So let's move now. Okay, now we will find here same as we have done earlier, kinetic energy and potential energy. Then we will find the total energy. Let's start with kinetic energy first. Okay, so kinetic energy is, I told you, energy possessed by body when it is in which state? It is in the state of motion. Clear? So kinetic energy formula is what? Half mv square. But children, at point B, what is velocity? V1. So can I simply write here half mv1 square? Yes, because velocity at point B is what? V1. So now what is V1 square? This we have already calculated. What is V1 square? What is V1 square? Half m into 2gx. Okay, so I hope it is clear. This we got already value of V1 square. Now one thing can cancel here. What can cancel here? 2 will cut with 2. What we left here? mgx. So this is the value of kinetic energy possessed by a body when it is at which position? B position. Clear? Now we need one more thing. Kinetic energy we got, that is okay. But we need one more thing, which is called potential energy. What we need now? Potential energy. So now children, potential energy formula is mgh. M is what? Mass. G is what? Acceleration due to gravity. What is H here? The distance from the, what we will say here, what is H? Distance that is from the ground. What is the distance of the point from the ground? It is H minus X. So can I replace here H with H minus X? Because this is the distance of the object from the ground. So potential energy is mgh minus X. Now total energy, children. Total energy, mechanical energy will be always the sum of kinetic energy and potential energy. So we have now kinetic energy with us. What is that? mgx. We have potential energy also. What is that? mgh minus X. Now we will solve further this equation. Simplify it with me. mgx. This mg is outside the bracket, so it will multiply with the each term inside the bracket. So what we will first get? mgh plus minus minus. mg into x is mgx. Here mgx will come. Now this mgx, here it is plus mgx, here it is minus mgx. They will cut each other. What we have left? mgh. This is the total energy. At which point? At point B. Look children, at point A also the energy is what? mgh, total energy. At point B also we got energy, total energy mgh. Now one point is remaining. What is that point? C. Children, now come at point C. Now at point C, children, again we will use the equation of motion. V square is equal to U square plus 2as. What is what is the velocity at point C? V. So we will write here simply V. What is initial velocity, children? 0. So it is 0. What is A? Acceleration due to gravity, replaced by G. What is S, children, here? What is that S here? From A to C. What is here now? Distance. Distance is what? H. This distance. So it S is replaced by H. What we got? V square 2gh. Now again we will find first kinetic energy. Formula is half mv square. So now children, we have the value of v square with us. What is the value of v square? 2gh. So we will put here the value half m. V square will be what? 2gh. Clear? What will cancel here? 2 will cancel with 2. What is left here? mgh. Okay, I think it is clear. The kinetic energy is what? mgh. Now one thing more we need to find here, potential energy. What do you think? What will be the potential energy at ground? Potential energy is an energy possessed by body because of its height, but because of its shape, size, or its position. Now the point C is on the ground. So potential energy is, the formula is mgh. But in this case h is 0 because the distance from the ground is 0. So the whole potential energy will become 0. So what will be the total energy at point C? Total energy at point C will be the sum of kinetic and potential energy. What is kinetic energy? mgh. What is potential energy? 0. So what will be my total energy at point C? It is mgh. So by this, what we are getting? We are getting the verification of the principle of conservation of energy. Look here, at point A, the total energy what we are getting? mgh, which is a sum of kinetic energy and potential energy. At point A, the total energy is mgh. We go further, we calculated the total energy at point B. again we have calculated kinetic energy, potential energy. Then what we got their total energy? Again we got the answer mgh. Move further, the object is under free fall. It reached at which point? C. When it reached at point C, again we calculated the two energies, kinetic energy and potential energy. Then we calculated the total energy, which is again come mgh. So this verification states that the sum of the energies, means the total mechanical energy of the system remains same, means principle of conservation of energy, that energy can never be created nor be destroyed, but it can convert from one form into another. Thank you, children.